Welcome to Business Reporter's Facilities Management Campaign. I'm Rachel Hicks. Even though facilities managers are busy, they never compromise health and safety for the sake of speed, especially when it comes to the use of handheld power tools, the overuse of which can cause irreversible injuries such as hand-arm vibration syndrome, or HAVS for short. Although legislation regulating the assessment and mitigation of HAVS was already enacted in 2005, non-compliance figures are still on the increase. With fines running to 6 digits and compensation per worker often reaching the tens of thousands, why don't businesses try harder to preempt injuries and the resulting compensation claims? Is non-compliance still cheaper than reducing exposure risks, or is it a lack of effective risk assessment methods that stands in the way of compliance? Well, this is what we're going to discuss today with Jacqui McLaughlin, the CEO of Reactec. Jacqui, thank you for joining us.
Thank you.
Now, tell me exactly what is HAVS and what causes it?
Sufferers of hand-arm vibration syndrome find it very difficult to carry out everyday tasks such as pulling up a zip, holding a glass, or playing with their children. It affects their ability to work, but also their ability to enjoy life. Hand-arm vibration syndrome is quite a serious issue. It's irreversible, and it's generally caused by the exposure to the hand and arm of harmful vibrations given off by power tools that they use in their everyday work.
So how many people does this impact, and how does it affect businesses?
The Health and Safety Executive estimate that some 2 million people in the UK are potentially at risk of developing HAVS as a consequence of the nature of the work that they carry out. It's currently the highest reported work injury, resulting in significant HSE fines, but potentially even more personal liability claims. Now, all of this would suggest that the current methods to manage the issue are just not doing enough.
So talk us through the current methods of understanding the risk.
Understanding your likelihood of developing HAVS requires an understanding of your exposure to hand-arm vibration. Understanding exposure requires understanding how much time you were exposed to that vibration, but also the magnitude of that vibration during exposure. Now, the more representative that exposure assessment, the more likely you are to be able to control the risk. Understanding the time involved in that exposure is actually quite straightforward, whereas the magnitude of the vibration can be an extremely challenging assessment to achieve. The challenge in establishing vibration magnitude during a tool use is there because any tool will give off a range of vibration magnitudes depending on who's using the tool and their ability to use it, what they're using the tool to do, and also the condition of not just the tool but also its accessory. Now, conventional risk assessments tend to just use one vibration magnitude for any tool in making those assessments, and that's because previously technology did not allow for a practical gathering of vibration data through the course of a working day. In this graphic here, I will show you just the extent to which that range of vibration magnitude can be impactful. This is data that's been produced by the Health and Safety Executive's laboratory, and there is a known relationship between a person's likelihood of developing HAVS and the assessment levels. In this particular graphic, if you look at the chipping hammer, if you were a user of that chipping hammer and you used it for, say, 30 minutes per day, at the lowest vibration level on this chart, then it would be said that you would have a probability of developing the disease within 12 years. By contrast, if your use of the tool resulted in a vibration magnitude at the top of the chart, then that time would reduce from 12 years to only 4.
So there's a real disconnect between conventional risk assessment and actual individual harm. Is there a way of illustrating how big that difference is?
I'll illustrate this again by use of another graphic. So in this particular case, in the graph you can see a black line. Now that black line is a very detailed task-based assessment of the risk that would be expected for an individual to face when carrying out a very specific task, but as part of a two-man team. On that same graphic, you can see Pete's actual measured assessment of his risk when he was in such a team doing that specific task. His actual risk is twice what you would have expected from that risk assessment, and is actually at a level where he's in serious danger of developing the disease. The data was all collected as part of a very detailed work study with a major utilities company. A number of 2, 3 and 4-man team were asked to carry out a very specific task several times over in order to establish a typical time for carrying out the task. It also involved carrying out very precise measurements with the latest standards of the actual vibration magnitude during the exercise. So the black line shows you the risk that would be expected for one individual when part of a 2-man team, using the typical duration from the work study and using an average of all the vibration magnitudes measured during the study. So that's the black line. What you can see with all the columns is all of the individuals who took part in the study, and for each of them, when carrying out the task just once, what was their maximum measured exposure in carrying out that one task. Now you can see there's a huge variability between the individuals. So what's the cause of that variability? For one, individuals do not work share in the way that you expect them to, and they do not all have the same skill level, which means that the vibration magnitude that they face is not the same as their colleagues.
How can risk assessment be better aligned with the actual HAVS risk?
Well, as one health and safety professional once said to me, how can I possibly put people to work safely if I don't understand what I'm exposing them to? Now, there are trigger timers which will readily help you assess the amount of time of vibration exposure, but to truly understand the risk for exposure to vibration requires a determination of real use tool vibration magnitude, and that's what we have endeavoured to do with our wearable product, HAVWear. HAVWear is unique in that it carries out 2 assessments of exposure to hand-arm vibration. In one mode, it operates as a simple trigger timer, and as such, it meets all the requirements of legislation and the very latest guidance from the HSE. This second mode is a real-time, real-use assessment of the actual risk faced by the wearer of the HAVWear product. This second insight gives managers an opportunity to see which individuals or which tools are causing risks that require their management, which previously they had no visibility of.
So how does it compare to conventional assessment methods? And has it, for example, had an independent review?
Yes, there has been a study by the Institute of Occupational Medicine, and from that study they concluded that HAVWear's real-time assessment of the use of multiple tools through the course of the whole day had distinct advantages over conventional methods. The nature of their study was some 62 different tools and almost 1,200 different tool measurements were taken to assess the suitability of the HAVWear's real use data against the conventional measurements taken according to the standard ISO 5349 when taken at exactly the same time.
So have your clients noticed a real difference?
Yes, obviously quite a number of them. A very good example is the sort of feedback that we've had from McGee, a leading construction company. They believe that Reactec's HAVWear will have a positive impact on the long-term health of the workforce. A senior operations director said, if you can't measure it, you can't improve it. He also said the range of statistics that we gleaned for the Reactec database is impressive, and over time builds to provide detailed information on such real-world factors. Not only does this information present opportunities when it comes to planning an activity by providing accurate data on vibration values, but over time it can be used to better identify required tool maintenance regimes, accurately predict consumable lifespans, as well as highlighting individuals who require further training in the use of tools.
So how does wearable tech ensure that facilities managers can control HAVs?
Reactec's HAVWear is a practical, personal, wearable monitor which can help facilities managers protect their organisations from commercial risk, but more importantly, ensure the long-term health of their workforce.
Jacqui, thank you very much for coming in and talking to us today.
Thank you.